Hello, dear students. This is RK sir. So, for purpose of inter-public exams, I will try to every student got good marks. So, in inter-public exams, that's why I'll explain chapter-wise important questions. So, easy method. That's why today we'll discuss about in work energy power second long question. So all of you listen carefully. This is 100% useful for your IPE intermediate exams. Okay, dear students, today we will discuss about so another long question in work energy power. That is question is here. So state the law of conservation of energy and in verify it in the case of freely falling body. This is the question. So everybody must be read question. So question is state the law of conservation of energy. So what is question here? State the law of conservation of energy. So in examination purpose, valuation time, statement, total complete question divided some parts. Statement have 2 marks as well as derivation, so some marks, diagram 1 mark, and added 1 or 2 small question or problem also. So everybody think about that type of valuation. Dear students, state the law of conservation of energy. Here statement is important. State the law of conservation of energy. What is the law of conservation of energy? Means here statement is there. Once listen all of you. Statement. The energy in the entire universe remains constant. The energy in the entire universe remains constant. Energy can neither be created nor be destroyed, but it can be transferred from one form to another form. This is the statement of law of conservation of energy. So what is the meaning of statement? Here actually the total energy, the energy remains constant entire universe. So energy can neither be created nor be destroyed. But what to do? So we will do, the energy can be converted to one form to another form. Sometimes heat energy, like the electrical energy converted to heat energy, as well as electrical energy converted to sound energy. So finally, here statement is the energy remains constant. Energy remains constant. Energy can neither be created nor be destroyed, but it can transfer from one form to another form. This is the statement of law of conservation of energy. That's it. Energy. That's why I write on one form here, one word, total energy, like that, here, total energy is equal constant, here, like that, maintain this one word also, right? This is the statement. So in question, and verify it in the case of freely falling body. So the total energy, here energy remains constant. So this statement verify in the case of freely falling body. What is freely falling body? Here this is a body. When remove my fingers, the body easily comes downward direction due to gravity. So here we will not apply external force on the body, but due to attractional gravitational force, so that's why the body is comes downward direction. This body is called freely falling body. So this total energy remains constant. This statement verified in the case of freely falling body. Here one diagram is there. All of you listen. Diagram here. Consider a body. Diagram is very important, Nana. Listen carefully. This is a body, like that. Now body. Now here this is a freely falling body. It is maintained some height from the ground. Here this is ground. This is ground. So that's why So this is position A. What is the height of the body from the ground means? So ground నుండి ఈ బాడీ ఎంత హైట్ లో ఉంది అంటే ఇక్కడ మనకి h హైట్ లో ఉంది అనుకుందాం. ఓకేనా? So here the body maintains some height h from the ground, right? So it is a freely falling body. In the case of freely falling body, here in this case the body is at rest. That's why initial velocity of the body is 0. That's why here u is equal to 0, 0. Right? When remove your fingers, body comes downward direction. Here చూడండి, this comes downward direction. So here ఇక్కడ మనం మిడిల్ లో ఒక పాయింట్ తీసుకోండి. దిస్ ఇస్ పాయింట్ బి. హియర్ దిస్ ఈజ్ పాయింట్ ఏ, దిస్ ఈజ్ పాయింట్ బి యాజ్ వెల్ యాజ్. చూడండి ఇక్కడ ఏ టు బి డిస్ప్లేస్ అయింది. ఎంత డిస్ప్లేస్ అయింది అనుకుందాం మనం? సో ఏ నుంచి బికి డిస్ప్లేస్ ఈజ్ ఎక్స్ అనుకోండి. ఏ టు బి డిస్ప్లేస్మెంట్ ఎక్స్ యాజ్ వెల్ యాజ్. ఇక్కడే ఉండదు కదా, ఇట్ ఈస్ కమ్స్ అండ్ సో హియర్ కమ్స్ ఫ్రమ్ గ్రౌండ్. Okay, at point B, velocity of the body is v1. At point like that, this is last point is C. The velocity of the body is v2. V2 from B to C. Velocity is v2. V2. Okay. Here now, all of observe diagram. Here you know this ground position to here point B. What is the height here? Total height from point A is h. Now I want height of the body from point B. Total height minus this displacement means here what happened? H minus x. This is the height of the position B from the ground. So everybody once concentrated by the diagram, because total derivation depends on diagram only. This is very important question. Okay, right. Now so what to do means, here once observed what is the total energy at point A, what is total energy at point B, and what is total energy at point C. Find the total energy at point A, B and C. So what happened now, observed here. Firstly you discuss about one by one. Point A, point A. So this total derivation depends on diagram only. That's why everybody focus on that diagram. Now point A, heading is point A. Point A here body is at rest. This is the first point A. This body some height. What is the height from the ground means h height. So at point A the body is at rest. That's why. So in this case the total derivation depends on two equations only. That is, one is potential energy, second one is kinetic energy. What are the expression for potential energy? You know already, PE is equal to mgh. What are the definition of potential energy? The energy possessed by the body by virtue of its position. చూడండి ఇప్పుడు ఇలా ఉంది అంటే ఒక పొజిషన్లో ఉంది. ఒక పొజిషన్లో ఉన్నప్పుడు ఆ బాడీకి ఉన్న ఎనర్జీ పొటెన్షియల్ ఎనర్జీ. ఎట్ పాయింట్ ఏ దగ్గర ఉన్నటువంటి ఎనర్జీ పొటెన్షియల్ ఎనర్జీ. ఓకే, సో here at point A, potential energy is PE. Okay na? So PE is equal to, you know, expression mgh. M for mass of the body, g for acceleration due to gravity, h for height. So ground నుంచి ఎంత height లో ఉంది? h height లో ఉంది. That's why this is the expression for potential energy. It is clear. Kinetic energy is denoted by kg. You know already expression. Kg is equal to half mv square. Last class work energy power లో మనం డిస్కస్ కూడా చేసాం. So kinetic energy K is equal to half mv square, where v for velocity, but at point A velocity of the body is u, where u is equal to 0. That's why here u is equal to 0. This equation can be written as K is equal to half mu square, where u is equal to 0. That's why K is equal to half into m into 0 whole square. 0 means 0 into something is 0. That's why Ke is equal to 0. Pe is equal to mgh. Kg is equal to 0. Now I want total energy at point A. So energy here mechanically converted to kinetic and potential energy. I want total energy. Total energy is equal to potential energy plus kinetic energy. So that's why here total energy, TE means total energy, A means at point A. Total energy at point A, PE plus KE. And add cheyalamma. So total means adding. Total energy at point A, it is equal to, what is PE? Potential energy is mgh. What is Ke? 0. So finally total energy at point A is equal to mgh. Mgh, this is equation number 1. Okay na? Finally, so at point A, the total energy is equal to mgh. Total energy is in the form of potential energy. Now, as well as find the total energy at point B. Find the total energy at point C. Complete derivation depends on potential energy and kinetic energy as well as diagram. Now, we will discuss about here point at point B. Point B. Right. What is point B? Here, once observed. Same potential energy. Want potential energy. Potential energy P. General expression for potential energy P is equal to mgh. Where h for height. Height. At point B, what is the height of the point B from the ground? Here, this is height. Chudandi ఒకసారి. Height of the ground. Height of the point B from the ground h minus x. Here h is equal to h minus x from the diagram. That's why PE is equal to mg. H means h minus x. What happened here? PE is equal to mgh minus mgx. Simple derivation, but focus on derivation. PE is equal to mgh minus mgx. Right? As well as find out kinetic energy also. At point A, kinetic energy 0 because body is at rest. That's why U is equal to 0, Ke is equal to also 0. Now I want kinetic energy at point Ke. Ke is equal to general expression of m v square. But here what is v at point B? What is velocity here? v1. That's why this equation can be written as v1 square. But I want v1 for velocity from motion of equation. Kinematic equations 4 is there na, dantlo third equation. So here from v square minus u square is equal to as. This is the expression 3, where v for v1 square minus u. What is u from the diagram? 0 is equal to into a for body comes downward direction due to gravity. That's why a is equal to g. A is equal to g, where s for displacement. Chudandi, a nunchi b ki enta displace ayindi body. This is important. Here h minus x is height, but displacement from a to b, displacement is x. That's why s is equal to x. Height into displacement ante meer clear ga chudagalagali. So that's why v1 square is equal to 2gx. Okay na? Right. Now v1 square value substitute in this equation. Kinetic energy is there. Ke is equal to half into m into v1 square. V1 square means 2gx. Right? 2 cancel. Ke is equal to m into g into x, mgx. This is kinetic energy. Now you want total energy at point B. Total energy at point B. What is total energy means? PE plus KE at point B. So total energy at point B is equal to, what is potential energy at point B? mgh. Right. Plus what is kinetic energy? Kinetic energy here. So potential energy mgh minus mgx ganana. Right. Potential energy mgh minus mgx. Kinetic energy is plus mgx. right? Plus mgx minus mgx cancelled. That's why total energy at point B is equal to mgh, right? This is equation number 2. ఒక్కసారి క్లారిటీగా చూడండి, డెరివేషన్ కొంచెం ఈక్వేషన్ ఎక్కువ ఉన్నా కూడా మనకు అర్థమైపోద్ది, ప్రాబ్లం ఏం లేదు. This is the total energy at point B is also mgh. Now we will find out total energy at point C, right? This is the point C. It is very simple derivation. So here at point C, right? Already first position body some height means h, second position point B means h minus x height from the ground. Now body is on the surface. What is your height? Already body ground పైన ఉంది. ఇప్పుడు బాడీ హైట్ ఎంత అంటే no height means 0. The body is on the ground at point C. Here potential energy PE is equal to general expression mgh, but h for height, what is h value? H is equal to 0 because the body on the ground. That's why PE is equal to m into g into 0 means PE is equal to 0. Potential energy at point C is equal to 0 because body on the ground, no height. Mg into 0, 0. Potential energy 0. Now find out here kinetic energy at point C. Same. What is the expression of mv square? What is the velocity from B to C means v2. That's why of mv2 square. Now find out, I want v2 from v square minus u square is equal to as. This equation same ikkada kada use chesam kana, right? Where here v means v2 square minus u means 0 here also because the body from పాయింట్ ఏ నుంచి వస్తుంది కాబట్టి ఇనిషియల్ పొజిషన్ మనం అదే తీసుకోవాలి. 0 is equal to v square minus u square, u is 0, 2 into a means a is g, a is equal to g. S for displacement, so here in this case చూడండి ఎక్కడి నుంచి డిస్ప్లేస్ అయింది బాడీ, మనకి ఏ టు సికి డిస్ప్లేస్ అవుతుంది. దట్స్ వై A to C, what is here distance h? This h converted to here displacement. That's why where s is equal to h, then v2 square is equal to 2gh. This v2 value substitute here, kinetic energy kg is equal to half into m into v2 square means 2gh. 2 cancelled, kg is equal to mgh. Okay, now I want total energy at point C. Total energy at point C is equal to PE plus KE. So total energy at point C is equal to, what is PE? What is potential energy at point C? 0. Plus what is the kinetic energy at point C? mgh. Now what is total energy at point C? It is equal 0 plus mgh. Okay na? This is equation number 3. Once observed equation 1, 2 and 3. What is equation 1? Total energy at point A, mgh. Total energy at point B, also mgh. Total energy at point C, also mgh. So finally, from equations 1, 2 and 3, the energy remains same. That's why the law of conservation of energy is verified in the case of freely falling body. In the case of freely falling body, that is the final answer. Dear students, so it is very simple derivation. So step by step observe cheyandi. Intermediate very important question. So that's why, so once all of you maximum practice is very important. Once again all of you listen carefully. I will try to everybody get IPE marks only after completion of intermediate public exams. I will clearly explain each and every topic purpose of MSET and mains level also. That's why this is intermediate public exams. Second long question, law of conservation of energy statement and derivation of law of conservation of energy in the case of freely falling body. From equation 1, 2 and 3, the total energy remains same. That's why the law of conservation of energy remains explained, so are verified in the case of freely falling body. So dear students, so once take write everybody to notes. So anyway, thank you.